everybody, welcome to another aviation ATPL theory video. My name is Konstantinos and I hope you are doing really great. Today we're going to be talking about the difference between indicated and true altitude on an aircraft and how we can calculate its true altitude if we know the indicated and vice versa. The altitude on an aircraft is measured by the altimeter, but the purpose of an altimeter is installed in an aircraft is to indicate an approximate distance between two pressure surfaces. In principle, an underage capsule measures static pressure surrounding the aircraft, and with a knob on the instrument you can set the reference pressure, for example QNH. The distance between these two pressure surfaces depends on the density of the air in between. So, since the density in most cases is unknown, the conditions of the standard atmosphere has been used, where density, pressure and temperature are known in calibration of the instrument. So the altimeter is constructed to indicate the distance between these two pressure surfaces in the atmosphere, and the altimeter thus only indicates the correct altitude in one instance, namely when everything is standard. It is thus important to understand how the altimeter works so you can correct indicated altitude to true altitude. The altitude from the reference pressure surface, for example QNH, the mean sea level, to the static pressure surface, to the level of the aircraft, depends on the mean temperature of the layer between these two surfaces and on the amount of pressure. Compared to the altitude indicated by the altimeter, the true altitude will increase with increasing temperature and with increasing QNH, and decrease with decreasing temperature and decreasing QNH. So let's see why. The general formula in order to calculate the true altitude is this. Which simply tell us that the true altitude is the altitude measured on the QNH reference plus or minus an error which depends on the temperature deviation of the actual temperature deviation from the ISA conditions. So, this is the altitude with reference to mean sea level. And this is the error due to the deviation of the actual temperature from the standard atmosphere temperature, and we can calculate it by this formula. Where this is the temperature deviation, the actual temperature deviation from the standard atmosphere deviation for the current altitude, which means that so if an aircraft is flying with QNH as a reference, then we have that the true altitude will be the altitude flying on QNH plus this or minus this error. But if the aircraft is flying with a reference to the standard pressure 1013 hectopascals, then Then the true altitude will be the altitude flying on QNH, which in this case is its flight level plus the pressure deviation from the standard, from the QNH, plus the temperature error. So, as we can see from the second formula, for an aircraft to fly with a safe clearance from the ground, the true altitude must be greater from the flight level indicated in the aircraft, which means that from the second formula we can see that this term is equal to and since of course this term is positive, this term is positive, and this term is positive, so these two terms must have this relation between each other, so that the total expression must be positive, or in other words, this term must be positive and this term must be positive, which means that if QNH is greater than standard 1013 and the actual temperature is greater than the ISA, than the standard atmosphere temperature, then we are safe. We can now have a look in a practical example. So let's suppose that an aircraft is flying at flight level 300. The QNH is 976 and the temperature at this flight level is minus 58 degrees Celsius. And we want to calculate the true altitude. Since the aircraft is flying on the flight level, we must first find the altitude of the aircraft, which is the altitude based on the QNH. So, this altitude is flight level plus the pressure correction, which is the first two terms from the formula. So since the QNH is lower than standard pressure 1013, then the altitude will be lower, and if we make the calculations here, we'll find that the altitude of the aircraft based on QNH is almost 29,000 feet. The second step is to find the temperature error. So, the temperature error, the deviation from standard atmosphere temperature, is the actual temperature minus the standard. The actual temperature is minus 58, and the standard is, let's calculate it here, it's 15 minus 229 minus 43. So the deviation will be minus 15 degrees. So the error due to the temperature deviation is going to be which is about 1760 feet. So our final true altitude is going to be the altitude based on the QNH minus the temperature error, and this is approximately 27,261 feet. So the true altitude is less than the indicated altitude in this case, and this because the QNH is less than the standard pressure 1013, and the actual temperature is less than the standard atmosphere temperature for that height, for that altitude. Of course, we can see it also on the second sketch, which is for when the QNH is less than the 1013. In this case, the altitude based on QNH is less than the flight level, and we correct for the difference, which is 27 QNH minus 1013. So this is the pressure correction. So that's all about true and indicated altitude. If you have something to add or any questions, you can write or comment below. Thank you very much for watching and have a fantastic day. I'll see you soon in the next video. Bye bye.